Hello everyone, my name is Mehmetcan and in this video I'll be explaining my E415 Unlock CMOS Integrated Circuits course project, which is designing an OPAMP and later on a quad OPAMP using Cadence. So the requirements of this OPAMP are given below with a supply current less than 10 milliamperes, a phase margin of at least 50 degrees, and an input common mode range of at least 0.7 volts to 3 volts. So the topology selected for this OPAMP circuit is given below, and this topology is later on created in Cadence as a schematic, and the widths and lengths of the transistors are given next to them, and the resistance and the capacitance were added for stability reasons. The test results are given below with a maximum supply current of 8 milliamperes, a output voltage range of 2.37 volts to 2.59 volts, an open loop gain of 52 decibels, a common mode rejection ratio of 61 decibels, a power supply rejection ratio of 69 decibels, phase margin of 52 degrees, and a bandwidth of 176 MHz. So for quad op-amp design, the bias circuit and the amplifier circuit were separated and later on created as schematics, which are later on turned into layouts. The layout design of the amplifier is like this. The MOSFETs were placed such that the design rules were satisfied. First, a DRC run was conducted so that the connection and substrate errors were corrected, and later on an LVS run was conducted which showed net mismatches and device errors, and later on corrected utilizing the places in the schematic, and later on a QRC run was conducted to get the AV extracted schematics. So for the bias circuit, the same principle goes as well. We have created it in the Cadence and later on created a layout in Cadence which we have run DRC and later on LVS and later on QRC for the AV extracted form of the circuit. So for designing a quad op-amp, the amplifiers were placed like this and the bias circuitry placed like this, and connections were made so that the layout was created. So the layout looks like this, with the input pins are given at the top and output pins given at the bottom, as well as the VDD and the ground rails for connections. The inside of the layout looks like this, where we have the bias line and the VDD line and the ground line, and each of these parts were connected to each other. The DRC run, the LVS run, and the QRC run were done in this part as well, and we get the AV extracted form of this circuitry later on. So the test result of this quad op-amp is as follows. The phase margin is 72 degrees and the bandwidth is 173 MHz. The phase margin increased drastically with respect to our initial op-amp design because of the parasitic capacitance effects and also resistance effects, as well as the bandwidth decreased slightly because of these parasitic effects. So for the noise analysis part, we have the noise as volts per square root of hertz. As the frequency increases, the noise decreases, but in the smaller frequencies, the noise is higher due to topology. So given below is the noise contribution of each part of the circuitry. The noise configuration, the noise contribution changes for each different part of the circuit, and the total summarized noise is around 3.39 times 10 to the power of -9. So thank you for listening.